Assalamualaikum warahmatullahi wabarakatuh and good day to all. I am Muhammad Zakir bin Yaakob. My student ID is 2023520371. Currently, I am studying in Master of Science in Mechanical Engineering, CEEM 750. Today, I will be presenting my progress report with the research title of Dielectric Materials for Electrowetting on Dielectric Mechanism. During my research, I was supervised by Dr. Elinadia binti Abdul Latif. For introduction, since the last decade, electrowetting on dielectrode (EWOD), which is derived from the phenomena of electrowetting, has been widely researched and worldwide acknowledged as a promising technique for liquid manipulation and actuation. The EWOD technology has been widely used for a variety of applications, including lab-on-a-chip, optical devices, thermal management, solar concentration, and surface research, due to the benefits of enormous pressures at micro-mesoscales, a quick reaction time in the millisecond range, and straightforward implementation. In addition, most of EWOD research aims to design the mechanism that will be reduce device power consumption, employ new dielectric materials of device, and optimize device size. However, various components with very inherent material qualities have distinct effects on the performance of an EWOD device. Digital microfluidics (DMF) is commonly implemented in two different ways, which are closed and open format. For the closed format, also known as two-plate format, as we see in left side of the picture, in which the droplets are placed between two electrode pattern substrates, the substrate contain driving and ground electrodes respectively, and the open format, which is we can see in the right side of the picture, also known as the single plate format, in which the droplets are arranged on top of a single substrate, which houses both actuation and ground electrodes. In both arrangement, an insulating layer of a dielectric material is put on top of the actuation electrodes to restrict current and avoid electrolysis. Generally, an extra hydrophobic coating is applied to the insulating layer to limit droplet adhesion to the surface. For problem statement, by reason of the costly materials that are typically utilized in the EWOD method, the overall cost to conduct the experiment may be labeled as high. Furthermore, the detailed study of the EWOD mechanisms for commercial polyurethane (PU) materials such as dielectric constant and dielectric breakdown voltage has rarely been performed till now. Therefore, the development of the alternative PU materials for dielectric component in electrowetting on dielectric device with low-cost materials and low-cost fabrication method for EWOD process may be able to resolve the issue. There are three objectives for this project. First, we need to evaluate the electrowetting response and the contact angle change with applied voltage of commercial PU materials. Next, we need to measure the dielectric properties, which are dielectric constant and dielectric breakdown voltage of the PU materials. And lastly, we need to characterize the surface morphology of the PU materials. There are four scopes of study for this research, which we can see on the slide. First, we need to understanding the fundamental principles and mechanisms of electrowetting on dielectric surface. This involves the manipulation of liquid droplets using electric fields and dielectric materials to control the wetting behavior on solid surface. Next, we need to exploring different dielectric materials, which is PU material, and their properties that are suitable for the EWOD mechanism. Furthermore, we need to analyzing the wetting behavior of liquids on dielectric surface under the influence of electric fields. Last but not least, we need to studying surface modification techniques for dielectric materials to control and optimize their wetting properties. These may include surface roughness, chemical functionalization, and nanostructuring. For literature review, we focus on do some research on previous studies that's similar to our research project title. Okay, firstly, Chang et al. Describe the characteristics of an EWAT device using aluminum oxide created by atomic layer deposition (ALD) for the first time as a high K dielectric for significantly reducing the EWAT driving voltage. The measured threshold voltage to move the droplet was as low as 3 volt, the lowest voltage reported so far in EWAT research. Next, Kumar et al. Focused on the possibility of using SU8 as a hydrophobic layer in conjunction with functioning as a dielectric in a device. It has been demonstrated that an SU8 microchannel in the current design permits microfluidic flow at tens of voltage, similar to more expensive and difficult to produce design reported in the literature. In addition, Abdelgawad et al. Show an innovative, simple and low-cost microfabrication method for digital microfluidics. In this article, devices are created from copper substrates or gold compact discs using rapid marker masking to replace photolithography approach. Besides that, saran TM wrap, polyethylene film and commercial water repellents were applied to replace frequently used and more costly materials such as Perylene C and Teflon AF for dielectric and hydrophobic coatings. Last but not least, a novel ion gel material was presented by Narasimhan et al. As a spin-coatable and high-capacitance dielectric was used in this research for low-cost EWAT applications. They studied the principles of an ion gel dielectric, its spin coating production technique, and its interaction with a hydrophobic layer in actual EWAT applications. For research methodology, we start our project by preparing all of the shelf materials, which includes plastic 70, acrylic base, CRC clear seal coat, PU base, and polyimide film Kapton. Then, we coating all of the shelf materials by using deposition methods such as spin coat, spray, and deep coating. Then we go on to the method that will fulfill the objective of the study. By we start the methodology by measuring contact angle with applied voltage for all materials, followed by observing surface morphology, which are thickness, roughness, and microscopic observation for all materials. And lastly, we analyzing dielectric constant and dielectric breakdown voltage for all materials. Last but not least, we investigated droplet actuation for all materials and end of the research methodology. For data collection and analysis, for now we doesn't have, so we plan to do in the next semester on October 2023. The slide shows the figure of Gantt chart that mention our activities for completing my research. So as we can see, there are many activities that we can do to complete the research, such as project title registration, conduct literature review, and all the research methodology that have been mentioned before. So for now, the project title registration, planning and scheduling, conduct literature review on electrowetting on the electric EWAT, preparing of the shelf materials, and coating all the off-the-shelf materials by using the deposition methods have been complete in this semester, and we hope that we can complete the other activities for the future. For status of publication, currently we prepare for review paper with the title of commercial hydrophobic surface for electrowetting on dielectric mechanism for the conference. So for now, the status of the review paper is I have submitted my first draft to my supervisor, and now I keep updating the review paper according to my SV's comment with addition for result and discussion. For status of thesis writing, as we can see that for chapter 1 introduction, I have been complete 65%. Next, for chapter 2 literature review, I have been complete 40%. Followed by chapter 3 research methodology, I have been complete for 25%. And for chapter 4 result and discussion, and chapter 5 conclusion and recommendation, I have not started yet. So my planning for next semester, first, I need to submit a review paper with title Commercial Hydrophobic Surface for Electrowetting on Dielectric Mechanism, as I mentioned earlier on status of publication. And then I need to attend 5th edition of International Science, Technology and Engineering Conference Global Advanced Material and Surface 2023. So for this conference, I will present on virtual mode. Then I will publish a journal paper based on the conference, and then I will do defend research proposal on September 2023, and data collection and analysis I will start to make it on the next semester, as planned is in October 2023. So this is the list of reference that I used earlier for literature review section. That's all from me. Thank you.